Welcome to Pepe's Civil class. Today's question is under fluid kinematics and dynamics. So, a pipe 200-meter long slopes down in 100. So, the pipe slopes down, in 100, and tapers from 600 diameter at higher end. So, the upstream, we have a diameter of 600 mm and 300 diameter at the lower end. The downstream has a diameter of 300 mm. It carries 100 liters of oil, 100 liters per second of oil, and specific gravity is equal to 0.8 if the pressure gauge at the higher end reads 60 kilonewton per meter square. Determine the velocity at 2 end. So you have to determine velocity at 1, velocity at 2, then the pressure at the lower end, pressure at 2. Okay, so neglect all losses. Let's start. Solution. Data given. We're given the length of the pipe, to be 200 meters. So length of pipe L is equal to 200 meters, and then the diameter at pipe 1 D1 is equal to 600 meters. We have to convert it to millimeters. We have to convert it into meters. We have 0.6 meters. So let's find the area at 1. Then do the same thing for area at 2. So A1 is equal to pi over 4, 0.6 squared, and this will give us 0.283 meters squared. That's the diameter of pipe at the upper stream. Now D2, diameter of 2 was given us 300 mm, and we have 0.3 meters. So we have A2 to be pi over 4 multiplied by 0.3 squared, area 2, and this is also going to give us 0.0707 meter squared. So we know the area at section 1, the upper or the higher end, then the area at section 2, the lower end. Now I have to calculate for the height of the upper stream, ZA, elevation at 1. We are not given the elevation directly, but we are given the slope. So we are given the slope. So for us to get the distance, the elevation, we have the distance and the slope, so you have to multiply. Therefore we have 1 in 100 slope multiplied by the distance 200 meters, and this will give us 2 meters. So the elevation from the datum line to the upper end, Z1 is equal to 2 meters. The lower end starts from the datum line, so therefore it is 0. Elevation at 2 is equal to 0 meters. Alright, so now we can let's calculate for our discharge, then we can calculate for our velocities. So the rate of oil, we were told that the discharge was carrying oil, right? Yeah, 100 liters of oil. So rate of discharge is equal to 100 liters per second of oil, and we have 100 multiplied by 10 cube, then 10 exponent 6, and this will give us 0.1 meter cube per second for our discharge. So yeah, that's, and what else was given? Pressure at 1 was also given. So P1 is equal to 60 kilonewton per meter squared. Okay, so I, velocities at two ends. So you can calculate for velocities at two ends, which is V1 and V2. Okay, so calculating for the velocities at V1 and V2, we use the continuity equation, okay, which is discharge is equal to the cross-sectional area at 1, velocity at 1, A2, V2. Okay, so from this one, you make V the subject, V1 the subject, we have V over A1. Discharge is equal to 0.1. A1, we had 0.283. So 0.283. And this is going to give us 0.353 meter per second. Okay, we said for the velocities at both ends. So the second part, we have velocity at 2 is equal to discharge divided by area at 2. Discharge, we have 0.1. Area at 2, we had 0.0707. So 0.0707. 0.0707. And this will give us 1.414 meter per second. Okay, so that is for I. If the pressure gauge at the higher end is reads 260 kilonewton, determine pressure at the lower end, so P2. Okay, now Bernoulli's equation, we have P1 W plus velocity at 1 squared 2g plus the elevation at 1 is equal to pressure at 2 plus velocity at 2 squared 2 multiplied by the gravity plus elevation at 2. Okay, we know pressure at 1 to be 60. So 60, we know our weight, but we have specific gravity. So 0.8 multiplied by our weight 9.81 plus velocity at 1 0.5 0.353 squared 2 by 9.81 plus elevation at 1 2 is equal to pressure at 2, we are yet to find 0.8 specific gravity by 9.81, velocity at 2 1.414 squared 2 by 9.81 plus elevation at 2 is 0, because it starts from the datum line. Okay, and now this whole expression gives us 9.64. Yeah, take your time and do your mathematics. Okay, you get it. And we have P2 divided by 0.8 by 9.81 plus 0. This one 102. Okay, so when we subtract this one 0.64 by 0.902, we have P2 over 0.8 multiplied by 9.81. 9.64 minus 0.102, we have 9.538. Okay, or 534. So make P2 the subject, multiply this one by this, we have P2 is equal to 74.85 kilonewton per meter squared.